Today, we will explain the use of the breaker tester. First of all, let's explain the accessory box and its attachments. First, open the accessory box. This is the signal wire of the sensor. This is the test wire, or the test wires. We will explain them separately later. This is the power cord. These are 2 rolls of printing paper. This is the universal support of the universal support. Then this is the body of the rotary sensor. There are 5 of them. 1, 2, 3, 4, 5. The single, port 1, which has 1 threaded hole. The accessory support with 1 threaded positioning hole. It is mainly used for the rotary sensor. This one has 2 positioning holes. And this is N10 and N12. It is used for the vacuum breaker, the accessory of the linear sensor. This is a rotary sensor with 2 positioning holes. The one with 2 positioning holes is used for the measurement of the rotary sensor, the speed, measuring support for the SF6 breaker. Then this is the test support for VS1. This is a strong magnet. This is the accessory of the vacuum breaker. First, let's talk about the linear sensor's accessories. The linear sensor and its accessories. So, we will explain the rotary sensor. The rotary sensor. This is the coupling for transmission. This is the body of the sensor. Then, using the support, it is fixed to the rotating handle. This is how the support is fixed, and this is connected to the connecting shaft of the breaker. With the movement of the breaker's shaft, the sensor can then measure its speed. And there is a very small dead zone. It is approximately 10 to 15 degrees. So, we usually keep it in the middle position. If there is 1 positioning hole, first, we connect 1 positioning hole to the breaker body. Connect and fix it. Lock it with a screw. Then connect it to the sensor. Connect it to the sensor. There are hexagon socket head cap screws as accessories. We can loosen it. After loosening it, then insert and put the sensor accessory in. Then lock it with a hexagon socket head cap screw. Lock it tightly with a hexagon socket wrench. After locking it tightly, it is equivalent to. This is fixed to the breaker body. This is fixed to the support. Then, when the breaker makes a rotational movement, the measured speed is obtained. The installation of the shaft and the sensor should be concentric. Otherwise, it will affect the measurement accuracy of the sensor, and distortion may damage the sensor. This is the rotary sensor. The installation method with 1 positioning hole. If on site, sometimes there are 2 positioning holes. The installation method is as follows. It's also very simple. It's similar to this. Then take out the one with 2 mounting holes. First, we position the 2 mounting holes of the sensor. Give it a position. Select different sizes of the positioning holes. Give it a position and install it. After installing it with screw accessories, we install it. In the same way as before, install and tighten it. Then, moving together with the breaker, the speed can be measured. This is the rotary sensor, used to measure the SF6 breaker, or for the use of other breakers. There is another configuration, that is the VS1 vacuum breaker. The accessory of the VS1 vacuum breaker, there is a hole on the side. We can insert the shaft into the scale. Insert it into the arrow groove. Then connect the sensor to it. When connecting, don't insert it all the way in. After inserting, the coupling won't be able to deform completely. Insert part of it. This way, the coupling can still deform. Then fix this handle. Then, when the breaker rotates together, it can measure the speed. This is the test of the vacuum breaker. Then let's talk about other accessories. If there is no positioning hole, not even one positioning hole, nor two positioning holes, then use this magnet. With the magnet, use a screwdriver to remove this handle. Remove it with a screwdriver. Remove it with the screwdriver. After removing it, it's possible to, first, attach it to the position of the rotating transmission pot by suction, then insert it into this, and tighten it with a screw. Then fix the sensor body. At this time, when the breaker rotates, it can measure the value. Generally, try not to use the magnet, because it may cause deviations. If there is no positioning, it may rotate. So, be sure to pay attention during the test. Then let's talk about the linear sensor. Regarding the linear sensor, it is used for the measurement of the vacuum breaker. If there are positioning holes on the moving energy storage shaft of the on-site vacuum breaker, for example, there are these positioning holes, such as 6mm, or 10mm, or 12mm positioning holes, or positioning holes of other sizes. We can use the positioning holes to screw it onto the moving shaft head, tighten it onto the moving shaft head. Then, at this end, we can after removing this, we can screw it on. Screw it on, then it can move up and down. If there is no moving shaft, and if it can't be screwed, then we can also use this magnet to attract it. Then fix it on this magnetic table column, and fix it with that support. Then it moves along with it. This is also possible. These are two ways for the vacuum breaker and some vacuum breakers have that rod on them, which can be fixed with this. After fixing it, remove it. Then it can also be screwed on. Screw it on. Remove and screw it on. Move along with it. This is about the vacuum breaker and the dialog flow breaker. The accessories of the sensor. The accessories used. The situation of the accessories. Then we can talk about other wires. Let me explain it to you. The current wires. Let me explain it to you. The power cord goes without saying. First, let's explain. This is the power cord. Goes without saying. Then this is the breakpoint wire. For the breakpoint wire, the previous A1, B1, C1 is a common terminal. A1, B1, C1, A2, B2, C2 share a common terminal. Then A3, B3, C3, A4, B4, C4. Their common terminal is this black wire. So, pay attention. We'll explain it in detail later. And that is. This is the extension wire of the breakpoint wire. Yellow, green, red extension wires. This is for the vacuum breaker. This breakpoint wire, you can see it has 4 wires, yellow, green, red, and black. There is a sheath in the middle. This makes it easier to connect. If it's not long enough, you can also extend it with this pack of breakpoint wires. because there are. It can be extended further. And since there are these extension posts in it, the extension transition posts, these transition posts are available. Then this is the breakpoint wire. After the breakpoint wire, this is the black one. This is the connection wire for the common terminal. The connection wire for the common terminal of the breaker. You can refer to the instruction manual to see how the common terminal is connected. This is the other end of the break point. If it's a 3 break point, this is the other end. If it's a 6 break point, it's the common terminal between two break points. Then this is the black short connecting wire. This is for the vacuum breaker. For short connecting in pairs. It's very short, quite convenient for short connecting in pairs of the vacuum breaker connection wires. Then this is the grounding wire. Then this is the test wire for the breaker's energy storage. For the two, Y1, red is positive, black is the negative of the energy storage wire. Then this is the closing and opening control wire. Insert the yellow, green, and red wires into the closing and opening control terminals, yellow, green, red, and for the 4, wire 1, the wiring is, when looking out, it's yellow, green, black. Yellow, green, black means that red is for the closing coil, black is the common terminal, green is for the opening coil. This is what was mentioned just now, or I made a mistake. This is the control wire for internal trigger. That is red, black, black, green. Red is for closing, black is the common terminal, green is for opening. These are all the test wires. Now explaining the main unit of the breaker tester. How to determine if it is good or bad. First, when we use it, we must take the instrument out of the box before it can be used, because the instrument is high-powered. It contains a high-power DC power supply. If it is placed inside the instrument box, it cannot dissipate heat. It is very easy to cause, for example, problems such as burning or something. Therefore, we must take the instrument out of the box when using it on site. It must be taken out of the chassis before use. Then we place it on a flat surface. First, let's take a look at this. Plug in the power cord. Plug in the power cord. Then power on. This is the grounding post. Clearly the grounding post. This is A1B1C1. A2B to C2. Their common terminal is shared with this grounding post. They are together, so its short circuit is at this place. Then A3B3C3. A4B4C4. Their common terminal is at this small arrow here. So it's a full wire short circuit line. The advantage of doing this is that the first two circuits and the last two circuits are completely independent. So if the front is broken, the back can still be used without affecting the contact gap. This is the closing red and opening green internal trigger control terminal and the common terminal black. Common terminal for opening. This is the positive and negative for energy storage. Then this is the lock release power supply. Then this is the external trigger. This is the sensor signal line. Then the USB interface. Okay, let's first explain how to determine if the instrument is good or bad. First, after we get the instrument powered on, these two buttons are for adjusting the LCD contrast. First, let's determine if the contact gap is good. Is the contact gap good? We have a short circuit line for the contact gap. We just said that the front 1 to yellow, green, red corresponds to the black socket. One end Then we find the wire. First, for example, we now connect the yellow wire to the black socket. This black wire is connected to the grounding post. Then we set the instrument to automatic test mode, or in the settings menu under parameter options, under the status detection. It can also be determined. For example, currently without a short circuit, its status is open. If we short it, its status will change to closed. A1 yellow green C1 B1. Yellow green red corresponds to ABC A1 B1 C1. When the test line is disconnected, the screen displays open. Similarly, this port is the same. Yellow, green green, red, yellow green red. All are the same, open. Then if we plug in this terminal, let me demonstrate for everyone. See, there is no change. Why no change? It has been clearly explained before. Its common terminal is independent. So you must plug into the black socket, because the back must use the black socket. So we use the black socket now. Then yellow A3, B3, C3. Similarly, the back one is the same. A4, B4, C4. This is how to determine if the contact gap is good. As I just mentioned, in the open and closed status, it is also possible. In the open and closed status, it is also possible when the instrument is on site, if the breaker is closed, but it shows open, then we need to determine if the test line is not connected properly. Then this is first the determination of the contact gap. Second is the voltage determination. Voltage determination. First, we select the voltage on the instrument. Voltage setting. We set the voltage. For example, we adjust it to 200,220 volts. Then our meter will also display around 220 volts. This meter is directly connected to the power supply. Then we can see from this meter, we roughly know if the instrument power supply is normal. If the meter shows no voltage, then this is definitely not normal. We can use the red and black probes of the multimeter. Plug into the open and close control terminal. Plug into the terminal, then we select manual open and close. Then we follow the screen prompt. Left button is close output, close indicator, light. The meter and the instrument both have power output. The multimeter also displays. Right button is open indicator. We set it here, right button open indicator. The multimeter display matches the screen. All three meters match, indicating that the voltage has output. First, the circuit is good, voltage has output. The energy storage is the same. This can also be shown to everyone. If we check the energy storage, the screen prompts left and right buttons for coarse adjustment, up and down buttons for fine adjustment. Press the confirm button to output. The multimeter outputs 220.4. Energy storage also has power. Press again to stop output. This indicates that the voltage is normal. Especially to mention this log power supply. The log power supply means it also shares the instrument power supply. The log power supply is the instrument. When preparing to close, if some breakers have a lock, we can use this power supply to release the lock. But note that this power supply has positive and negative. The power supply must pay attention to the positive and negative direction. All power supplies in the instrument are in one direction, from positive to negative. You cannot short circuit positive and negative. Short time short circuit will not burn the instrument, but short circuit for a certain period of time. Surely, the instrument's power supply will burn out. So when we connect it, the positive terminal of this power supply must be connected to the positive. That is, in the positive direction. All the positive terminals should be in the same direction. We must ensure this. When the breaker is closed, the unlocking power supply. We can also demonstrate it. First, there is no power supply. In this state, there will be power. At this time, it enters the state before testing. Then there is power. When you press it for power output. After the output ends, there will be no power supply again. There is no electricity. This is the unlocking power supply. If we have judged these points. First, the contact gap is normal. Then the opening break power supply is normal. The energy storage is normal. The unlocking is normal. This indicates that generally, there are no major problems. Then let's take a look. Use the sensor to check it. Whether the sensor's testing function is normal. For example, first we connect the sensor wire and insert it into the corresponding interface of the sensor. We choose to set it. Select this as a rotary, linear sensor. We choose linear. Then we can choose to turn on the stroke. The sensor stroke is 50 mm. So when we measure the stroke, we choose 50. We choose an arbitrary speed setting. An arbitrary speed setting. We just want to see if it can work properly and test whether a curve can be obtained. Okay, let's simulate it. At this time, the simulated speed should be relatively fast. As soon as the verification pointer lights up, I'll finish pulling. Otherwise, it will end in 250 milliseconds. Then there will be no curve. Or, at this time, look, this is a curve. Judging from this curve, it shows that that is, this area, for this stroke measurement, and this speed measurement, this channel is also good. Based on the above points, we can judge whether our instrument is in good condition or not. Of course, a rotary sensor can also be used if there is no linear sensor available. Or, when I want to determine whether the rotary sensor is in good condition, it's the same. We can plug in the sensor wire and then insert the sensor. Then we can also choose the simulation method we used just now. That is, rotate one turn. We can also choose in the parameter options. Under the parameter options, there is the status detection. In the status detection, we can see, during the rotation process, the cursor is moving evenly. That indicates it is in good condition. There is no problem. If we stop, the cursor will not move. If the cursor is shaking or something like that, it means there is a problem with this test channel. This sensor. Regarding the sensor and the accessories of this instrument. How to detect whether the sensor is in good condition or not. We'll stop here. Today we'll explain this breaker tester. It is used for the testing of vacuum breakers. We'll give a demonstration to you all. First, we connect the contact gap line to the upper port. Yellow, green, and red correspond to A, B, and C. Then the lower port. Use the special short circuit wire for the vacuum breaker. Short circuit it, then lead it to the instrument through this black wire. This is the wiring of the contact gap. And this clip must be clamped firmly, otherwise, it will vibrate. And this is the sensor. The sensor we use is a linear sensor. Connect the moving contact head with the linear sensor. Then this universal magnetic stand. The universal magnetic stand, socket on. Then conduct the test. Now let's explain how to do the wiring. And these wires. We have led them here through this terminal block. Led them down to the ground. First, we take the instrument out of the chassis. Put it on the ground for testing. Test. First, we at the side. First, we connect the ground wire to the relay post of the instrument. Make a reliable connection. Then connect the power supply. Connect the power supply together. Power on. The power supply is not turned on. Then adjust the contrast of the LCD on site. First, we take the contact gap line. First, short circuit the breaker short circuit wire, grounded, and the contact gap lines A, B, C correspond to yellow, green, and red. We can choose the first channel A1, B1, C1, yellow, green, red. Then connect the short circuit wire to the metal grounding post. Then it's about the energy storage of the closing air brake. Then connect the wiring for closing, opening, and energy storage. And the control wire of the closing opening brake. Red, green, black. Red represents closing. Black represents the common terminal. And green represents opening. First, after connecting these wires, there is also the signal wire of the sensor. The sensor signal wire. Align the 5-pin plug with the notch. Insert it in. OK. Then the wiring is done. First, we need to energize the breaker for energy storage. We press the OK button. Bring out the cursor. We need to move the main cursor and the sub-cursor to settings. Under settings, there is an energy storage control option. Enter it. Press the OK button to enter the energy storage control. The current voltage is 220 volts. Press the left key as prompted. Press the OK button for energy storage. Power output. The instrument is energizing for energy storage. We can hear the sound. OK. Energy storage is completed. Then we press the OK button. The screen shows energy storage completed. Then press the return button to exit. Try not to press the return button to exit directly. This may, well, the internal relay may have logical problems or get damaged, because it needs to turn off the relay of the small power supply first, then turn off the large power supply. Then we can operate at this time. First, conduct the setting and testing. In the settings, we first choose internal trigger, the internal trigger of the instrument. Then select a duration of 250 milliseconds. Normally, we can choose 250 milliseconds, which is enough. There's no need to choose others, unless it's for reclosing or other special breakers. Then we need to lengthen the duration. Normally, 250 milliseconds is enough. The breaker will surely move within 250 milliseconds. Then select item A. Now it's the linear sensor. Select the linear sensor. Then the stroke. The linear sensor can test the stroke. If the linear sensor at the customer site, well, its length can be customized. Our standard configuration is 50 mm. Then select the test stroke. So turn on the stroke test. When testing the test stroke, what is input here is the total stroke of the sensor. For example, if the total function of the sensor is 50, our sensor, the total function is 50. If the customer orders a 200 mm sensor, then input 200 mm here. Then select the speed definition. The speed definition of this vacuum breaker. It means the 6 mm before closing and after opening. This definition. If there are many fixed definitions in it. If not, we choose the instrument self-definition option. After choosing the self-definition option, we make settings here. Make settings in this speed definition. You can see the instant of contact closing, the instant of contact opening, how many milliseconds before contact closing, how many milliseconds after contact opening and closing, how many millimeters before contact closing, how many millimeters after contact opening and closing. percentage of the total stroke before contact closing, percentage of the total stroke during contact closing. According to these definitions, it can be self-defined. Then save it. And then start the test. These are the definitions we set, and at this time, we know it means the 6 mm before closing and after opening, so we change it to 6 mm before closing and after opening. Then we select the closing coefficient. The opening coefficient is generally used by breaker factories, or for a special breaker. It has some conversion coefficients for measurement. At this time, the conversion coefficient is equivalent to the last level. Just save it. Then we can start the test. And there is another thing. We check some parameter options. There are some functions in the parameter options. We need to select to turn them on. Look at this speed waveform. It is generally used by breakers. We can ignore it. Over, charging, over, stroke and rebound. If needed, we check the box. If not needed, we just cancel it. 3. Phase display. If needed, turn it on. If not needed, turn it off. The 3 display is for 3-phase. We'll demonstrate what the 3-phase situation is like later. And at this time, the energy storage is completed. The energy storage is done. We can conduct the test. The previous one is the automatic opening and closing test. And this is the reclosing. This is the operating voltage test. This is the instrument's life test. We mainly want to talk about. We can first explain the automatic test. When conducting the automatic test, our contact gap must be connected to the AEBCE contact gap. It can then be recognized. It can recognize several other contact gap. When installed on other contact gap, we must manually select whether it is a closing or an opening test. We now select the automatic test. And now all the settings we made are there. Press the OK button. The breaker should operate. The breaker has operated, and then the data will appear immediately. This time, 48.33, 48.1, 48.88. And then it's bounce. The bounce of phase A, the bounce of phase B, the bounce of phase C. The inter-phase synchronization is the maximum minus the minimum. The maximum minus the minimum is 0.67. And this is the speed of phase A, 0.72. The speed of phase B is 0.73. The speed of phase C is 0.71. The over stroke is 4.4 to 0.52. The maximum speed is on the stroke curve. It is calculated by taking a point every 10 milliseconds. The maximum speed. What is the over charge? What is the coil current? What is the stroke? Then we can take a look. This is its waveform. We can choose to print. Select page printing. It will print the current test results. It can print the current test results. We can also choose to save. It will be saved in the device. So even after we turn off the device, we can still open it. The last set of data can also be opened. That is the result of the test just now. And now if we turn off the 3-phase display, close it among the 3 options, we turn off the 3-phase display, then it won't display properly. This is how it looks when displaying. There is no 3-phase speed. There is still one speed. We need to calculate quickly. The speed mentioned is the closing speed. The others are the same. The bounce won't be displayed. Then the bounce interface will be displayed here. It's displayed here. It's displayed here. Phase A bounces once, 0.39. Phase B bounces twice, 1.65. Phase C doesn't bounce. This is about the 3-phase situation. Then we restore it to the 3-phase display again. Let's take a look. Do an opening operation. Also select the automatic test. OK, we select the opening test. Bigger test. Press the OK button, and the breaker operates. It operates and the data appears immediately. We can hear the sound. Let's see what the speed is. What's the starting value, the maximum speed and rebound? The coil current and coil resistance, the waveforms are all there, and at this time, we energize it for energy storage again. Turn off the power. And we just saw the opening operation. Let's print it out. The opening time is about 25 milliseconds, around 25-24 milliseconds. Now the breaker is closed. We can do the reclosing. When doing the reclosing, for example, when the reclosing breaker is closed, then we can do open, close, open. We can also do close, open, close. So let's do a close, open, close. The first time is 300 milliseconds. We set it here. Look, it prompts that the reclosing time is greater than the set time. Reset. What's the reason? It's because in the test settings we did just now, the duration we set was 250. Setting 500 is enough. Normally, when we do single, open or single, close, 250 milliseconds is more than enough. Then we do close, open, close, and select 300 milliseconds. The second time should be 10 milliseconds greater than the closing time. The maximum closing time is 48. 10 milliseconds greater. We select 60. OK, when we press the OK button, the breaker will operate. Well, now the breaker is on. Now let's check the breaker state. Now the breaker is in the open state, so it can only do close, open. Let's close it first. Let's close the breaker first. Close the breaker first. Then energize for energy storage. Then we can do close, open, close. Press the OK button to exit. Then press the return button to exit. Press the OK button to turn off the power. Press the return button to exit. Then we can do close, open, close. The settings we made just now are still there. Then press the OK button. Its state is closed. So, for the close, open, close operation, press the confirmation button. Then it will start to operate. Then for the close, open, close operation, the time of the first open, the time of the second open, the time of the first close, the null, current time, the short, circuit time, and then the initial open speed. The speed of the first initial open, the speed of the first initial close, the speed of the second initial open, the current now. All these data are available. You can print or save it if you want. This is the reclosing. Now, let's do another demonstration of something else. The operating voltage test. First, we can energize it for energy storage. Now the breaker is open. We want to do the operating voltage test. We have several methods. 3 methods. The first one is manual opening and closing. After entering, if you want to do the operation voltage test with manual opening and closing, first, we adjust the voltage. For example, if I want to know at what voltage, manual opening and closing at 30%, 220 volts, 67%. For example, now we want to know if it can operate at 53 volts. We select manual opening and closing. Yes, select manual opening and closing. Now it's 53 volts. The breaker is closed, but we were in the open state first. Now we close it. Let's see if it can be closed. See if it can close. It can close after 1, 2, 3 attempts. This is the manual method. If I want to adjust the voltage, when it's adjusted to the right value, when can it close? Now, it's closed. This is the manual opening and closing method. The opening operation is the same. And this is the automatic tripping. Well, this is the manual tripping. There is also a manual tripping method. Manual long voltage tripping. That is, you set a time. Set a voltage. It will increase automatically. For example, we set the initial voltage a bit higher. We set it to 37 volts. OK, then we press the OK button. Then it will increase step by step according to your set step size, step by step. When does it operate? Hey, 37 volts. It didn't operate. It didn't operate, it didn't operate. This is equivalent to this. It's a semi-automatic state. When it operates, you stop it by pressing the stop button. Press the OK button. Record the time when it operates. Then, for example, record whether it operated. Then you can print it. Then at this time, let's demonstrate again. This automatic low voltage tripping. Automatic low voltage tripping means you don't need to interfere throughout the process. Don't need to do anything. Just connect the contact gap line and the closing and opening brake control line. Don't connect other wires. Then you select the appropriate step, size, and other voltages. Then it can automatically select. You press the OK button. It will increase automatically. When it operates, that's it. It will stop increasing the voltage. Then at this time, you can choose to print or do whatever you want. So, the 3 low voltage methods, I've explained them to you all. This data can be stored in a USB drive, stored in the instrument file. It can be exported through a USB drive and printed in report format on a computer. Okay, the breaker has operated 113 volts. It has operated, so now we can print it out. For example, just print it by pressing the return button. Since this breaker is an odd one, its operating voltage might not be 3% of the rated voltage. It might not operate at 30% of the rated voltage. It's normal that it doesn't operate at 67 volts, and its reliable operating voltage is 80% of 220 volts. 80% of 220 volts is more than 100 volts. Okay, now it can operate at over 100 volts. That means there is no problem. This is all for the explanation of this breaker tester.